Going back to this blueprint we have, what if you want to not set them individually, but every single time to have a random color? You may just want to search for it and search random color, and you will get this linear color set random hue. What you need to do is put your light color here, and this back here, and put this back to here, and press play, and they're randomized every single time. To understand what this node does, every single time this node is run, it sets a random value to this variable, and this variable is set as a light color on event begin play. You may wonder, why does the color set are not same for all of them? We only edited one option, one blueprint, and they are all in the same blueprint. So why is the value different for each one? This is because this process is called for each actor individually. So if you press play and go to their blueprint, you will see this node. Let's repeat this process. This red line is the function that just was triggered. And if you take a look at the top side here, we have different lamps, and you can select any of them. So let's say select blueprint second one and click on the light color, etc. Everything is in place, and you may not notice a difference. And you can even check the other ones. But if you pay attention here, when I hover over the light color, the values here are different for each one. And this is because while they are all the same blueprint, they are individualized. They are individual actors in the scene. So when an event is run for each one separately. So if you have an object with, let's say, this specific very simple 2-node event, and you have hundreds of the same object, you must keep in mind, during event begin play, you run not 2 nodes of complexity function, but 200. So make sure you don't clutter your scene too much. There are ways to optimize this, obviously. You can sequence, you can combine all actors into group actor. For example, instead of having 100 individual one light blueprints, you could perhaps have a light system for your whole city and have them, all the lights share the same blueprint. So in reality, it becomes one blueprint that's being applied to all lights in your city. But again, whether it is optimized or not, easier to use or not, if it is necessary, depends on your game, your creativity, and more importantly, when it comes to optimization, your ingenuity. Now, we have this function that is not bad. Every time we take a look at this room, it's a different color. And perhaps this is classy enough. Perhaps this is all you want. I want it to be a bit more brighter. So let's do 40. Let's see if that changed anything. Just a bit. let's change the authentication radius and angle a bit, maybe 60. Yeah, this is more to my liking. But I want this not to become stale, so this will remain exact same way for the rest of the game until I shut it down and begin it again. This is if it was a game, this would be like akin to entering a room, and the room has all these different colors, and each time you enter that room and that room gets loaded into the game or level opens up, you get different colors. It may be a bit boring, so let's make them change colors constantly. If we remember event tick, if we add this everything here we have into event tick instead of event begin play, we will get something very different. But I believe we can all agree this is too much. This is hurting my eyes. As such, this is not ideal. Yes, it changes constantly, but I don't want it to change that much. And this does it only once. We need a middle ground between over time, repeating function, and just single ones at the beginning. There are quite a lot of ways to do it. You can add timelines, you can call events, etc. But easiest way in this particular case is to add a delay node. What delay does, it waits a certain amount of time, and that time is referenced here, duration by duration. And after that time has elapsed, it executes. Let's put in 1 second. Now, let's take a look at this and think what it does. During begin play, meaning when this actor is in the scene and game begins, or when this actor is created or spawned, this triggers. We set a random color to our light color variable, which is set as the light color for our spotlight component. And there is a delay here. And 1 second elapses and this delay executes, but there is nothing here. We want to repeat this process. We want to select a new random color and select a new set it as a new light. So what we can do is take this execution pin and put it here. But suddenly this is very uncomfortable to look at. What we can do here is add a rewrote node. So let's add this node here. And let's drag this all the way here. Drag this node from here to here. And organize this a bit better. Now we have a node that re-executes here by delay after 1 second. And let's see what happens. Let's go back to the level and press play. This is much more pleasant to the eyes. Now, let's talk a bit about blueprint organization. If you are not the only one in the team, or if you just want to keep it organized, which is a good practice in general to always have your code organized, there are things you can do. One of them is, as I have shown before, is a rewrote node to make it easy to see where the execution pins go. So in this case, execution pin went from delay to linear color set random hue node. But this doesn't really explain what this does. And for a person who first time looks at it, they will need to go through the code to understand it. And if you have a very complicated code that has hundreds of nodes in it, which is not uncommon, you will have the person who takes a look at the code will have a hard time. To make it easier for them, you can select all of your code and click C button. This is common. For people who are familiar with coding in C++ or C# or any programming language, this is doing exact same thing. This does not add any cost to the project that is packaged for deployment. Here in the comment section, we just name this. Let's say light change function. I'm not sure what is going on with my keyboard. And now we have this, and we can change the color as well. If we want to make it different or just color code or functions. I prefer green, and we don't want to add this event begin play into this because event begin play will function regardless of this code inside. And now, since this is all inside this comment section, you can just move them all together, which is useful when you will have a lot of nodes in your level. There is one more thing about this I need to mention before we move on. This delay node here, you must pay attention. This has an icon here. If you read it, there's a text at the very end. Latent nodes can be only placed in event graphs. You may wonder why this is here. For those not familiar with the coding, I will have to explain what a macro is. A macro and functions are they are pretty much the same as what we have here, but the difference is they are happening instantly and cannot be time sensitive. By that I mean, let's say we have a function, and I don't mean this. These are nodes in a sequence. A function, if we were to create one here, let's say we click on this plus icon and create a function, and call this function, let's just call it test, as we are testing. Now we have a function called test. A function can be called as an event or a node, to be more precise, inside your blueprint. And I want to have this all happen inside a function. I could just copy this and drag this into the test, but it's much easier to remove this and click all of them and right click and collapse to function. You will notice this will fail. The reason why this failed is because of the delay node. We dismiss this. Let's do it again. This time without delay node selected. Collapse the function. Now we have a new function. And let's just copy the name of this and rename this new function into light change function. And event begin play this looks more organized, And it is also very good way to do this if you are going to reuse this function specifically in multiple places. Imagine you have a light and you have multiple possible triggers to change its color. Usually what you would need to do, you would need to copy paste this. You can remove this rewrite node. Really? You would need to copy paste this function to each one of these triggers. So for each event that has a possibility to change the light color to a random color, we would need to copy paste them and place them around the event graph, which will very fast make it very disorganized. But what's more important, unoptimized. An optimized function is a slow function, and a slow function makes for a slow game, and no one likes a slow game. Now we have this light change function, and we can trigger this exact same code by multiple means. Perhaps you have a game where, let's say, when you touch the light, it changes to a random color. When you perhaps perform a certain action like jumping, it changes to a different color. Or perhaps you shoot it, and let's say you have all three mentioned possibilities in the same game, and you want to do all three with the same actor. Will you create 3 separate events and copy paste that same spaghetti of code to everywhere? No. What you will use is this light change function. Now, you may wonder, but okay, if I have multiple ways of triggering this function, I would want to have more control over it. For example, in the aforementioned scenario, if you can shoot as a light and you want the light to change into, let's say, red color as if it's damaged, you cannot do this with this function because we set it random every single time. So there would be no real difference between by shooting this, let's say, lamp, which triggers this function, or let's just say walking around, or maybe there's just another trigger, doesn't matter. You would need more control over it. You would want to set this light color depending on how event is triggered without copying all this function everywhere. This is where inputs and outputs of the functions come in. So as you can see here, we have light change function and there are no inputs there. Targets is self in this case, obviously, but it can be something else if it's casted. Casts will be explained in the next lecture. We can click on the light change function and add an input. Also, we can add an output, but in this case, we are going to focus on input. Let's add an input. Input, in this case, is a variable. Now, this light color is a variable called light linear color. So we want this to be exactly the same. So we can just type it, linear color, and let's call it just color. And now, suddenly, we have a light change function with a color node that we can put into set light color instead of using light color variable. I will, for now, detach this. We may reuse it later. And we can compile. Now, if you go back to your event graph, you will notice, wait, we have a color. We now have a way to dictate what color it will be through a function. So let's make it, let's say during event begin play, when the function is called, it turns red. Save, compile, go back to the level. Press play. Okay, it works. But we used to have random colors. So this is what was enabling us to do it. So what we can do, we can cut this from here, compile, get back, and paste this code here for now.